Hi guys, in this video what we're going to do is going to look at compound interest and depreciation, and we're going to be using the compound interest formula. So very quickly, the future value f to which a principal grows at the rate of I per annum, compound interest after t years is f is equal to p1 plus I to the power of t. And this is really important guys, the rate of compound interest stays the same throughout the period and no sums of money are added or removed. So it's just like putting an amount of money into the bank and the bank paying 3% per annum per year and just leaving it there and not withdrawing or taking any money out. And then the future value will tell you what it's worth after so many years, which is your T. The principal is how much you invested, and then the 1 plus I, the I is the interest rate. Now it's really, really important guys, the interest rate. Okay, so I'm just going to write this down for you. The interest rate is written as a decimal, so written as a decimal. Okay, so just make sure that you write it as a decimal. So we'll just go straight through and have a look at an example here. It says what sum of money invested now at 4% per annum compound interest will amount to 1052.87 after 4 years. Give your answer correct to the nearest euro. Whenever we do these guys, all we do is we write down what we know. So F is equal to, P is equal to, I is equal to, and T is equal to, and then we can stick them straight into the formula and rearrange and solve as necessary. So we know that we've got 4% per annum. So I said to you to write it as a decimal, and 4% is 0.04. The future value, it says will amount to, so that's going to be my future value. So I now know that my future value is 1052.87. And we see here that we've told it's 4 years, so T is equal to 4. Get the formula, put everything we know in, and we can solve from there. So we know F is equal to P1 plus I to the power of T. Our F is equal to 1052.87. Our P is what we're trying to find out. And then what we have then is 1 plus I, so that's 1 plus 0.04 to the power of 4. Okay, just tidy that up slightly. That's equal to P, and hopefully you can see that's 1.04 to the power of 4. Now we're trying to get P on its own, so all we're going to do is we're going to divide both sides by 1.04 to the power of 4. Okay, that means what we'll end up now is that P is equal to 1052.87 divided by 1.04 to the power of 4. You then get your calculator out, put in the information, and then what you end up with is P is equal to the nearest euro, 900 euros. Right, let's have a look at the second example. So this time what we're going to look at depreciation, which is otherwise known as the reducing balance method. So you can see here, again, we have a formula. Again, the same caveats as before. We're not putting any money into the system. We're not taking any money out. And you can see here, it's F is equal to P1 minus I to the power of T. Again, don't forget that I has to be written as a decimal. So let's have a look at example 4. So as a company buys a machine on the understanding it will be able to dispose of it in 8 years' time for 10% of its original cost. Find the annual rate of depreciation as a percentage correct to 2 decimal places. Okay, so again, we've got to look at our F, our P, and our I, and our T, and see if we can actually work out what these things are. So straight away, we can see here that we know what our T is. So that there is my T. It's going to be 8 years, so T is equal to 8. We have that from the information. We don't know what the initial price or the initial cost of the machine was, so we'll just call that P. So what we have is P is equal to P here. We know that T is equal to 8. We don't know what I is at the moment, and we are looking for our future value. But you can see here it says the future value will be sold or disposed for 10% of its original cost. And the original cost is P here. So 10% of P we can rewrite as equal to 0.1p or P over 10. That means that what we have here now is we have I is the thing that we're trying to find. It says find the annual rate of depreciation, and the annual rate of depreciation is going to be I here. So let's see what we can do. So put everything into the formula. So we've got f is equal to p 1 minus I to the power of t. So our f here is 0.1p is equal to p multiplied by 1 minus the I we're trying to find out, so that remains as the variable here, and t is equal to 8. Now hopefully you can see on both sides we have a p, so they're going to cancel, and we now end up with 0.1 is equal to 1 minus I to the power of 8. Okay, we have a power or something to the power of 8, which means that we have to undo this something to the power of 8. And if it was a square number, so if this was 1 minus I squared, then what we'd do is we'd take the square root, but it isn't 1 minus I squared, it's 1 minus I to the power of 8. So what we have to do here is we have to take the 8th root in order to get rid of this, and that means we have to take the 8th root on this side. So let's do that. Now we can write that as 0.1 to the power of an 8th. It's just easier. You could, if you wanted to, so 0.1 to the power of an 8th is exactly the same as the 8th root of 0.1. Doesn't matter how you write it, both are correct and acceptable. And that's going to equal 1 minus I. From here, what I'm going to do is I'm going to take the I across the other side to make it positive and bring this across the other side so that I can then have I is equal to something. So you can see what I've got now is I is equal to 1 minus 0.1 to the power of an 8th, and that now means that I can stick it directly into my calculator to get an answer. If I do that, what I'll end up with is 0.25011, and that means that I have an annual depreciation of 25%.